Hi, in this video we are going to talk about how to convert dash and wedge structures to chair structures. So before we go ahead and solve actual problems, let's remember the skeletal structure of cyclohexane molecule. Each carbon, depending on where it belongs on the chair conformation, it has a particular orientation for its bonds, namely they are axial bonds or equatorial bonds. And remember that if the axial bond is going up, the equatorial bond goes down, and if the equatorial bond is going up, the axial bond goes down, and so on and so forth. So in this particular skeletal structure on the screen, what you're seeing is that all the bonds that are going up are in a purple color and all the bonds that are going down are in the blue color. And why they have been color coded like that, there's a reason for that, and we'll go over that. Now what you want to remember is that whenever you're converting dash and wedge structures to chair structures, you want to remember that you're trying to look at the molecule from the top. So your view is such that the cyclohexane molecule, you can imagine it's in your hand, this particular chair structure, and you're trying to view it from the top down. So when we try to convert cyclohexane molecules from the dash and wedge to the corresponding chair, you want to remember the skeletal structure. Now let's look at this particular problem here. I have a particular cyclohexane molecule which has an ethyl group, a bromo group and a chloro group, and I want to place them on this cyclohexane chair. Now the first thing is we always label our carbons. It's good to label or to number so that we are sure on which part of the cyclohexane chair we want to put which group. If you have started labeling them such that they go clockwise on the skeletal on the dash and wedge structure, also label them the same manner clockwise on the cyclohexane chair. And I started from the head carbon of the cyclohexane chair, but you can start from literally any carbon and the chair would still remain the same. So what you're going to do is you're going to number them as 1, 2, 3 and 4. Now let's look at this dash and wedge structure. We know that the ethyl group is going away from us, so it is going down. So all the groups that are going away from me, I'm going to say they're going down, and all the groups that are coming towards me, I'm going to say they are up. One thing to notice here, I didn't make any claims about equatorial or axial, because for me, when I'm looking from top down on that cyclohexane chair, I am just looking at whether the bonds are coming towards me or going away from me, and that's what your dash and wedge structure is also representing. So the bond that is going down on the first carbon is actually equatorial down, right? So on the first carbon, I see that the bond is going equatorial down. So I'm going to place that ethyl group going equatorially down, right? On the second carbon, it's bromine, that is also going down, and the bond that goes down is the axial down bond, right, on the second carbon. So I'm going to place the bromine here. And on the third carbon, there's nothing. On the fourth, I mean, there are 2 hydrogens, but on the fourth carbon, you have a chlorine that is coming up. Now the bond that comes up on the fourth carbon is equatorial up, right? So I'm going to place the chlorine right here, right? So this is the chair which is a representation of this dash and wedge structure. Of course, we have the other chair conformation which results from a chair flip, and we'll go over how to do chair flips in the next video. But before we go ahead and do that, let's solve one more problem. So I'm going to solve this second problem here. What we have is, again, let's draw the chair, and this time let me draw it the other way around. Right, so this is the other chair. Now again, if I start 1, 2, 3 clockwise, I should go 1, 2, 3 clockwise on this one as well. Right, now carbon number 1 has an OH coming towards you, so that is going up. So all the bonds that are coming towards you are up, all the bonds that are going away from you are down. So carbon number 1 OH coming up, the head carbon on this particular chair is going to go axial up. So this is going to be OH. On the second carbon, the chlorine is going down, right? And we know that axial bonds are alternate. So if the axial up on carbon number 1, axial bond on carbon number 1 is going up, the axial bond on carbon number 2 is going down. So chlorine is here. Now on carbon number 3, the bond that goes down is equatorial down, right? Because again, alternate bonds are going, 1 and 3 are going to have both the up bonds as axial, the down bonds as equatorial. So the methyl on carbon number 3 is going to be this, right? And again, this will have a chair flip, corresponding chair flip, which will result as the cyclohexane conformation changes from one chair to another. But this is one of the chairs that represents this particular formula, dash and wedge formula. Let's quickly do one problem where we are trying to convert a chair structure into the corresponding dash and wedge structure. So what I have here is a dash and wedge structure, is a chair structure. Again, I am going to number. And why number? Because it just saves me the trouble later on of, if I don't number, we tend to make mistakes. So it's easier to just number and know on which carbons you want to place the groups. So I have 1, 2, 3, 4, 5 going clockwise on the chair. I have 1, 2, 3, 4, 5 going clockwise on the dash and wedge structure as well. Now the chlorine is coming axial up, right? So it's coming up. So I'm going to draw it coming towards me. Okay. So all the up bonds are coming towards me, all the down bonds are going away from me. This particular tertiary butyl group here is again equatorial up, right? So the up part is more important. So it's equatorial up, it is coming towards you, right? And on the fifth carbon, you have a methyl group going down. So it's, remember that on the fifth carbon you have a hydrogen that is going axial up, and the equatorial methyl group is going equatorial down. So on the fifth carbon I am going to have a dash structure such that the methyl goes equatorial down. So what I have here is this particular structure such that the corresponding chair is now converted to the dash and wedge structure.